it's easy for us, or easier for us, to see how we can find the area of a rectangle when the numbers are nice and simple and they are integers. So when, for example, in the last video, we talked about 7 square units 4 times. It's a little bit more complicated and harder to visualize when we are dealing with fractions. So here we have the area of a rectangle, but instead of using integers, we have some mixed numbers here. So we have 3.5 times 2.5 to find our area. What does that actually mean? What does that actually mean? And how can thinking about what it actually means help us to find the correct answer? Because sometimes we get confused and we misapply the multiplication algorithm for mixed numbers. So helping us to see this visually might help to think about whether I'm getting the correct answer or not. So here I have a diagram representing our rectangle, 3.5 centimeters tall, or wide, maybe long, I don't know, and 2.5 centimeters long or wide here. So you can see that we have some, we can count up some full boxes, but then we have some partial boxes over here. So really what we're dealing with in each row, just like we did before, we can break this into rows, and we have here 2.5 boxes, squares. Here we have another 2.5 squares. Here we have another 2.5 squares, and here's where it gets tricky. Here we have half of one. We have a half here. We have a half here. And here we have a half of a half, which is a quarter. So we're adding up all of these square units. So we're adding 2.5 plus 2.5 plus 2.5. So let's see if we can figure that out. 2.5, half plus a half is a whole, and a half. So we have 1/2, and we're going to carry our whole. 1 plus 2 plus 2 plus 2. We have 7.5 boxes, 7.5 square centimeters. And then we have a half plus a half is a whole and a quarter. So we have 1.25. So now we have to add these numbers together again. Oh, fractions. So we have 7/8 wholes. And then we have to find our common denominator here. So we're going to change 1/2 into 2/4 and 1/4. And we end up with 3/4. So, wow, that was a lot. And again, the tricky part is we have a half of a whole, and then a half of a half over here. So to do it with the algorithm, here's how we would do it. First thing we have to do is we have to change these mixed numbers into improper fractions. Oh, do we remember how to do that? 3.1/2. So how many halves are in 3? That's how I like to think about it. Or we could multiply 3 times 2 and get 6 halves. 6 halves is really, and you can look back up here to my diagram if you want. 6 halves is really 3 whole pieces. And then we've got 1 half here. So we've got a total of 7 halves for our first piece, for our first number. And then we're going to do the same thing with 2.5. So 2.5, how many halves are in 2? Well, again, we could look at it this way and look at these 2 pieces. So we're going to split them each in half, and we end up 2 times 2 is 4 halves plus 1 half. So this is going to be 5 halves. So we've got 7 halves times 5 halves. And when we multiply fractions, we multiply everything in the top or the numerator and then everything in the bottom. So we end up with 35 fourths. That's good news because we're going to end up with fourths over here in just a minute. But let me move this down here. 35 fourths. Remember I said fractions are really just division problems. So we can go from 35 fourths, 35 divided by 4. How many times does 4 go into 35? Well, it almost goes 9 times. 9 times 4 is 36. So it's really going to go in 8 times. 8 times 4 is 32. And look, we have 3 left over. 3 fourths left over. So whether you do it in the algorithm or whether you think about the pieces, hopefully this helps you to see how the area formula works a little bit better with fractions.